Hello webs, hi. This is Fahad from Future Phones, and today I have a very interesting case, and that's why I thought it's best to share with you guys. This laptop came in for a LCD replacement job, but when I looked at it, the LCD physically is okay. There is no backlight, however, on this LCD. So I mean, if you can look here, I'll show you in this camera here. You could probably see some shades of the colors that are inside, but since there is no backlight, so we can't see it fully, and we cannot control the backlight. So this is, I think it's in the BIOS at the moment. Yep, and you can see there is some graphics underneath, but there is no backlight on it. So when there is no backlight on a laptop, there could be 2 or 3 reasons. Either it's not coming from the board, the flex could be faulty, and the LCD could be faulty. So we will check all these 3 and we will diagnose. Okay, one thing before you want to work on the LCDs and all that, you always remember to take the battery off, so battery should not be connected. Now I have already tested the voltages that are coming on the LVDS connector. If I take you to my desktop, I'll show you here this board viewer, and I'll take you over there. That's my board viewer, and this is my LVDS connector here, 4501 J4501. So I have tested all these voltages are coming, plus 3 volt LCD, plus 3 volt LCD, and plus 3 volt sus, and as well as on pin number 23, 24, 25 and 26 we are also receiving LED VCC. So at this point usually is like 18 volts, 12 volts. There's some higher voltages available on these lines, and then we have ground pins here. So, and this is something for the camera. I have tested these voltages are available. Another thing that I have tested is I've got another LCD which is broken, but it has a working backlight circuit on it. So we will test this LCD now. I mean, there was so much information I learnt about this LCD LVDS panel that it was worth making a video, because it will also help me later on in the future. So okay, there you go. So I've connected the battery, and this is another LCD which has no display, but it has a working backlight. So we can test if this LCD shows us backlight. That means our LVDS connector, our flex, they are all okay. The thing that we need to work on is this LCD, or we can change it. So yes, you can see, and we have the backlight showing up on this broken LCD. So that means we have some issue on the LCD. It's showing the display, but it's not showing the backlight. That's why the customer thought it's he could change the LCD, and you can fix this laptop straight away. But I found this as an opportunity to learn something, and when I've learned something, I wanted to share with you guys as well. So this is our LCD, and this is our the panel underneath this LCD. So I've opened it already. Okay, now there is no schematics for this particular board. So this is the board number B140XTN03.3, and this is also called control board. So we are going to work on this one now. So how this control board works, um, we'll see here. I mean, okay, so this is where the LVDS connector, the flex goes in, and then this is some graphics ICs probably, but the section that we are interested in is this here. So you see, we are supposed to receive 24 volts on one of these pins here, and if I remove this, so 24 volts should be available on this line here. If it is available, if you can see the one in the middle, it should have 24 volts available. If this 24 volt is available, then our backlight panel will work. And also there is one more thing, since there is a control for the backlight, which is like sometime you want full brightness, sometime you want low brightness. In cases like this, there should be some control where you can have either 24 volt, 22 volt, 20 volt, or maybe 19 volt. So the higher the power, the more brighter the LCD would be. So there should be a control. We cannot have 24 volt available here all the time, so there should be a control as well. So for when it comes to controlling power, most of the time that I've seen is that we have switching power involved in this sort of situations, where a switch that can control how much power will be given to the board or output, it will be controlled switching power. And switching power is in the switching form, on and off form, and then we use a coil and a diode sometimes to convert that switching format into a smooth DC. So the same situation we have in this circuit. Let me take you to the microscope here, and I will show you what I have found out on this one. Sorry, it's just okay there. So if you can see here, so this is our 24 volt lane here. So this is coming from here. We have a resistor, and we have these two capacitors. They don't look in a very good shape, this one especially. If you can see, there is some damage here. So this is the faulty LCD where we did not have the backlight. So this is the one, and you can see there is some damage here. This cap looks, definitely this cap needs to be investigated. So well, anyway, so this 24 volt is coming through this resistor, and these are two capacitors here. Their job is to smooth the output from this switching power IC. So if I put it this way, here you can see that we have one output coming from here, pin number, this will be 5, 10, 15, 16, pin number 16, and this output is going to this coil here, and from this coil is going into this diode, and from this diode we are going into this cap, this couple of caps here, and here it will be like a smooth DC, and through this resistor we will pass this 24 volt or less or more to this connector here, and then this backlight should work. So there is a fuse also here. You can see there is a fuse. In most cases this fuse goes faulty. So on these type of LVDS LCD panels, you can always find two fuses, one on this side of the LVDS connector here. So this is also worth checking if this is blown. So in most cases, previously and in today's case as well, one of our fuse is broken, but it is not this one. The fuse that is blown is here. This fuse is blown. We will test it, how this fuse was blown, and the fuse was blown due to a reason. There was a reason, that's why this fuse was blown. And usually when there is a short circuit somewhere in the line, and the current is passing really fast towards the short circuit, this is when your fuse will blow. High current will also break the fuse. So these are some situations. Now the IC that I had a real big problem was with this. So this is an IC AU0 L10216, and I could not find any schematics for this, but I was going through some other ICs and I got the basic concept that this here will provide the switching power here, and through this coil this switching power will go past this diode, and this diode will filter it into the smooth DC. Okay, now there is one more thing here. So this is a controlling, I mean, if you think about it, so this is another output from this IC, which is on pin number 5, 10, 15, 16, 17, 18. So there is two outputs from this IC, number 18 also, but number 18, if you look here, number 18 is going into this cap and this resistor, and then this fuse and this cap, and is coming back to this coil. So I think this number 18 output is a smooth DC already. So this is a kind of LDO type of power that will generate, because I don't have any schematics, so I'm just guessing whatever it is. But since it's not going past this coil at this stage, so this can't be a switching power here on this pin number 18, but on pin number 16 it is definitely a switching power. So that I was talking about the control of the backlight. This is how it is done actually. So we are receiving, let's say, 12 volt here. This is a DC volt, so this is a permanent voltage, 12 volt here. But this switching power can be less or more depending on the command that we receive from our Super IO, that increase the brightness or lower the brightness. So this pin number 16 will control that additional power that will inject into the 12 volt line. Now it sounds complicated, but if you look at it, so if you see here, pin number 18 is generating 12 volt here, and through this resistor, fuse and cap, it is coming back to the coil. So we have 12 volt available here at this point. But when this 12 volt will come here, it will also find a switching power supply that is coming through pin number 16 into this coil, and this could vary. I mean, this could be 12 volt, 7, but it's in a switching form. So when it is in a switching form, so one voltage this IC is generating is in the switching form, and the other voltage is already generating is in the DC form. Now this 12 volt and this switching form voltage, it could be 10, 11, 5, 7, whatever. So depending on how bright you want your LCD. Now we have 12 volt here and switching power here. This switching power will add up with this 12 volt, and when this both 12 volt and switching power will go through this coil and into this diode, it will get rid of the switching form, and it will mix both 12 volt DC and the switching power. It will mix them both, and it will produce a smooth DC here, that will be a combination of 12 volt and let's say 5 volt switching forward switching volts. So that 12 and 5 will make 17 volt available here. If it is high brightness, then it could be 24, 27, we don't know, but that is the concept behind this circuit here. And well, this is how it works. Let's do some basic testing since we know what the concept is. Now my multimeter is in the beep range. Okay, what I have found usually is this resistor, this fuse goes faulty. So you can see, okay, this is the fuse. So you can see this fuse is not beeping. It's like a disconnect. There is no connectivity. So we have another fuse here. We will test this one, and you can see this is a good fuse. So this fuse definitely needs fixing. Okay, one more thing, since this metal panel, we can consider it as a ground, so we'll use one probe here, and the other probe we will look for any shortage on these caps as well. So you can see, so this is a ground side, this is a power side, that's fine. This is ground side, this is positive size. And I was doubting here already that these two caps, they don't look in the good form. So you can see this is the ground side and this is the power side, which is coming through this diode, and this is also showing short, this is also showing a short. Now two things we can start to work at. Okay, so my course of action should be, I will fix this fuse and I will remove the shortage. Okay, so to do this, fuse is easy. I will just throw a wire on this fuse. Now before I do that, let's try and get rid of these two caps and see if we can get rid of the shortage. So I have put a metal shield here to protect it from the heat, and underneath the board and between this film, plastic film, I'm inserting this aluminium metal shield that will also save it. So we have a little bit protection here. Okay, I'm going to put this as a weight. So I have a doubt on these two caps already. So let's go in the microscope. So since this one looks more discolored, so I'm going to remove this one first. Let's check for the shortage again. Oh, this is our ground test, and I will check for the shortage here. So this is ground side, this okay. Okay, we don't have a short anymore, you see. So this cap was in the bad condition anyway, so we will just check it one more time. If this cap is faulty, yes, it's in a very bad condition. You can see it's broken and all that. Oh, can you see that? See, it's broken from underneath. Is it short? It's short also. Okay, so these are the obvious faults that we should get rid of as soon as possible, because after that we can do a test and we can check if our 24 volt is coming to the backlight panel. Now the next thing is this fuse. Just throw a wire on this fuse. Okay, I will tin my wire first. You can see, if you want to see, yeah, you can just tin your wire. Okay, so this wire is tin now. It has a plastic I don't know, it's got some shield on top of it, this wire. So yeah, now it's easy. Just a little bit of flux, not too much. Okay. So yes, I have just made the jumper on this fuse, and I'll just make it a little bit better. And this should be okay for this. This should fix it. Let's see. And we will get some voltages. So get rid of this extra flux. So our fuse is okay, the shortage is gone, and so this is how it looks like now. So that's the fuse. I'll just test one time. So ground check. So this fuse is okay, and there is no shortage on this line anymore. So since this cap was faulty, so this could have caused all this damage. Time to check now, and how we are going to check is we will just connect this LCD connector, and battery connector here. Oh, sorry, you couldn't see that big board. Yeah. So now the battery connector. Yeah, battery connected. Now I will check power it on, and do we have a backlight? So the LCD has changed its color, so we still don't have a backlight. You can see, so we can see the background writing, but there is no backlight. So let's quickly check what happened here. So go back into the microscope. So we have the multimeter on now, and we are in the voltage range, and what we were supposed to check is what sort of voltages this is called a booster IC as well, this one. And what it does, if you give 12 volt to this IC, it will change it into 12 volt, 14 volt, 24 volt, and what this does, it changes. If you give 12 volt to this IC, it will change it to 24 volt, 27, 28, depending on how bright the LCD is. So let's check what is the output on this IC. You can see 11.58, almost 12 volt here. So this is on the resistor as well, and now we have on this capacitor, we have on the fuse, Okay, so both side we have the on the fuse we have this voltage available, and this is going back into the coil here, and this is where we are supposed to receive the switching power as well. So we are not receiving the switching power here. This is our problem. So we are not receiving 12 volt or 5 volt or 7 volt whatever through the switching power side of this IC. So this IC has some issue here. So this IC has few testing points here. So one of them is this resistor. Let's see. So it's a 3.2 voltage. It's probably the enable voltage. We have another 3.2 voltage. So if we are receiving 2-3 volts going into this IC, that means our enable section is okay for this IC, and that is probably why it's generating half of the voltage, but rest of the switching power is not being generated. There could be some other reasons, but let's investigate this first. So what is here? 0. So okay, what is this cap doing? Any voltages here? No. We are receiving 3 volt. Since we do not have schematics for this IC either, so we are running in the blind. But one thing we know, that this IC is generating 12 volt, but this side, on this side, the switching power is not being generated for some reason. And we can check our diode if this diode is faulty. For that I will remove this battery first. Okay, so I have removed the battery, and I'm going to investigate in this area what is happening here. Okay, let's see. This is our diode here. So we are in the diode range now. So this is the diode's value. This should be open line. That's okay. We have another diode here, open line, swap around, diode's value, that's fine. Okay, I want to also check this coil. If we have a connection here, oh, so something is not right between this coil, because this coil has become a simple wire. If you see here, it's all 0 0 0. So you can imagine this this is coming, this is an output line here. This trace is output, is going through this side of the coil and into this diode. However, if you check this coil, because coil has many loops of the wire, and that loop has some resistance as well. We're going to check what sort of resistance is available in this coil. If there is no resistance, that means this coil could be short. Okay, let's check. So this is like 0.05, which is the value of when I connect these two together. So you see, I'm connecting these two probes together, and I'm still getting 0.05. And when I connect this probe on both sides of this coil, I'm receiving 0.05. So that means there is no resistance in this coil. So if there is no resistance in this coil, our best bet is to get this coil out and check. Maybe this is one reason, since switching power supply is supposed to go past this coil, and this coil has become just a wire. So that's why its IC is not generating switching power supply, and we can't see it. So next step, let's remove this coil. So let's get rid of this coil. once we've removed, we will test this coil as well. So leave it here for testing. And I have some donor panels here to probably extract. So when the LCDs are broken, I just keep these panels safe. I just save them, so I could extract a coil or any IC from here. So I think I've already extracted one coil from here, so I think this is the good contender. We can remove this one. Okay, now this is the donor board. We come out nice and easy. Yeah, okay. Sitting, it's fine. Let's give it a try. I'm quite sure that should be okay. Okay, now what we are going to test is okay, we have the coil in there, a new coil, and we will test the LCD. Let's connect to the LVDS connector. Let's connect the battery. Okay, we have all the connections, everything looks good. Let's test if we have the 24 volts now. Is my battery connected properly? Yeah. No. Yeah. Oh, look, it's all working fine. So we have the backlight working now. So that coil was faulty as well. That shortage at that capacitor caused too much damage, and the coil was faulty as well. Just let's give it a check as well. I'm going into the voltage range. So now my backlight is working. So let's put my theory into practical, and we will check if our switching voltage is being generated now. Oh, yep. So this is our panel. Oh, I can't see it now. Oh, it's better. Okay, so this is where we were receiving 12 volt before. We're still receiving 11.3 12 volt, and we were not receiving any switching power supply here. You see, now we are receiving 11.31, almost 12 volt. And so the mix of this 12 and this switching is going through this diode. Now you can't see anything here, but at this side you will see that we should have 24 volt available. Come on, where are you? Yep. You see, we have 24 volts. So this 24 volt is going into this cap. Again, in this cap we can put a cap here, or we can just leave it, that's fine. So at this resistor we are receiving 24, at this side of the resistor we are receiving 24, and this 24 is going into the backlight section here, and that's why our backlight is working. You can see our backlight is working. You have you can see here, where is it now? You can see the light. This is the indication that the backlight is working. So the problem solved, and it took me some time to figure it out, because this is the very first time I have worked on a LVDS panel. I mean, it was quite straightforward. Only problem that I had was I could not find the schematics for that switching power IC. If I had found it, then it would be much easier, but I figured out that there was one voltage was a DC output, and the other output was in the switching form. So once I figured that out, I knew that that switching form of 12 volt is not being generated by the IC, and that was caused because of the faulty coil. So the coil can also be faulty, and it's not something that you should put out of context, that is not never gonna be the coil. Coil can also be faulty, and we just experienced, because of the faulty coil, our switching power was not being generated. So that's anything can be faulty, anything can go bad, and we need to figure it out. Okay, I hope that you must have learned something from this video. Do like and subscribe to the channel, and if you have any questions, you can leave in the comment section. Thank you very much. We'll see you in the next video. Thank you. Bye.